In 1915, Einstein published his groundbreaking theory of general relativity. According to his theory, space and time are intertwined. Together, they form a four-dimensional fabric called spacetime, and massive objects can warp that fabric. Now, everything in the universe, including light, travels through spacetime. So, if the gravity from a massive object warps spacetime, the path that light travels in can seemingly bend. This blew people's minds. Up until then, the concept of gravity came from Isaac Newton. In his worldview, space and time were absolute and independent. So, Einstein's idea was really radical. The problem was, there was no way to test his idea in the lab. His equations predicted that only a truly massive object could warp spacetime enough to make the light-bending effect visible. Something as massive, for example, as the sun. What's up, dude? Luckily, just 4 years after Einstein published his famous theory, a total eclipse allowed an astronomer named Sir Arthur Eddington to test it.
Eddington actually went out to test that theory during the solar eclipse of 1919, and actually photographed stars.
The eclipse was going to occur just as the sun was crossing a distant star cluster. Scientists knew where these stars normally appeared in the sky at night. If Einstein's idea was right, then when the massive sun crossed in front of those stars, it would warp spacetime and shift the apparent position of the stars farther from the sun. But usually, the brightness of the sun would make the stars impossible to see. During that solar eclipse, when the moon blocked out the sun's light, the stars were visible, and Eddington measured the effect. Woohoo!
The ability to see objects that were actually behind the sun proved that objects could warp space-time.
His experiment demonstrated that light curved as general relativity predicted, leading Einstein down the path to stardom. Flawless! Oh my god. Einstein! Oh my god.